Exactly. If you have to eat it hot.
All right, let's see where we left off last time. We had our roll a ball dealy thing, right? Was that completely done?
No. You not finished the count.
Oh, that's right.
We were gonna do the count.
Okay. I didn't assign that to you? Oh, because we're going to do a, that's right. So what we can do right now is the camera follows us, right? And we can go and collect these things, but we probably want to go ahead and have something show up on the screen that gives us, a count, the number of things that we've collected. Some sort of feedback for the user. Okay? By the way, I just set a new world record for how fast the board can be cleared. Just so you know. Okay, so let's start off with getting some text showing up somewhere. All right, so a couple of issues we have here is if I go ahead and click on the main camera. Right now, the camera, here's the main camera. Right now, the camera follows the ball. So if we want to have something that shows up on the camera, we can create a canvas, we can create something, but it's going to be a child of the camera. So let's look at a couple different ways to have text show up in here. So I'm going to take the camera, I clicked on it, I'm going to right click, and we're going to go ahead and we're going to add a UI element, and let's add some text. Okay, let's see, can I add that as a child of the camera? I think so. I know it's meant to stand alone, but I think you can, if you make it part of the camera, it'll always be in front of the camera. So let's see if this is. How do I get the text by the camera? All right, so we're going to say 0, 5, and then I'm going to actually say 0 for this. I don't see the text showing up. Let me kill this. I mean, I can do 3D text, but I really want to show you just the UI element. Well, the background isn't. Well, but it was way off the screen anyways. I mean, I could put 3D text in front of me, but what I really want is I want to have kind of like an interface that follows me around. So that way, in a game or something like that, you can show points and that kind of stuff. So because you could definitely in Unity 5, you could add a UI element as a child to a.
Would it be part of the GUI layer? Under the camera?
I mean, where do we even get this set? Okay. Let's make this say 15. And you're thinking, well, the color of the text looks like it is black. So let's make it size 30. See the text first. All right. I'm thinking we need to rotate. Where's my text?
I think it's just an empty text box. There's no text on it.
No, I put text in it. I put a 15.
Maybe it's really, really small.
Okay. Yeah, it's turned on. Okay, so now it's size 300. Centered. I guess possibly. I set the color of it. Maybe you do need to make a material for it. Let's do that. We will make it our red material. I assume you can use a canvas in 3D space, can't you? All right, let's look this up real quick. Unity, canvas, text, 3D. All right, and count text is a text. Okay, so this is where they're displaying text using Unity's UI toolset. Oh, this is actually the rollerball tutorial. It was what, 2 minutes? What am I on? Which network am I on?
To display text in this assignment, we will be using Unity's UI toolset to display our text and values. First, let's create a new UI text element from the hierarchy's Create menu.
Okay, we did that.
Let's look at what we've added to the hierarchy. we seem to have gotten more than we bargained for. We don't just have a UI text element, but we've also created a parent canvas element and an event systems game object. These are all required by the UI toolset. The single most important thing to know about these additional items is that all UI elements must be the child of a canvas to behave correctly. For more information on the UI tools, including the canvas and the event system, please see the information linked below. Rename the text element count text. So let's customize this element a bit. The default text is a bit dark. Let's make the text color white so it's easier to see.
Oh, I bet
The
you.
size and
I bet you the rule is that we can't make it a child of. Let's just in case I broke it. So we'll go back to main camera. I don't think I broke everything else. Okay, we're good there. So I'll right click, we'll create a new UI text, and there's our canvas. Okay, now we have some text with it. So the issue was that when we tried to add it as a child to our camera, we broke it, I guess. That's what I did, and I think that's what broke it. But I'm guessing we need to have that move around too, because I want it to always be on the screen. I don't think we should make it the child of anything.
If you go to canvas, you can set the position for the camera. Yeah, on the arch, with the anchor. Above it,
Screen space camera. So we create the canvas, then we let him know about the camera. So let's run this here real quick. To make it a lot closer. Well, that didn't seem to do it. So I have it rendering relative to the camera. I told it the camera it should be rendering. I gave it a distance.
maybe the distance needs to be negative.
Could be. Like you're thinking maybe it was behind us?
Yeah.
Let's make sure we can even see the text right now. Yeah, there's the text. Maybe it's a rotation issue. Let's see if
alignment are good. And let's add some placeholder text. Count text. We want our text to display in the upper left of the screen when the game is playing. We can see that the UI text is currently displaying in the center of the screen in the game view. This is because the text element is anchored to the center of its parent, which is, in this case, the canvas. It is worth noting that the transform component on UI elements is different from the other game objects in Unity. For UI elements, the standard transform has been replaced with the Rect Transform, which takes into account many specialized features necessary for a versatile UI system, including anchoring and positioning. For more information on the Rect Transform, please see the information link below. One of the easiest ways to move the count text element into the upper left is to anchor it to the upper left corner of the canvas, rather than to its center. To do this, open the Anchors and Presets menu by clicking on the button displaying the current anchor preset. When we re-anchor this text element, we also want to set the pivot and the position based on the new anchor. So we will hold down both the Shift and the Alt keys, and then select the upper left corner button. That's done it, it's up in the corner. But now it looks budged up against the corner of the game view.
Okay, so when we made it part of the camera, so you want to do this. You want to have it. But it's not putting it at the center of our screen. Let's create it again. So I'm going to go the center. We'll create UI text. We'll give it some new text. We'll make it bigger. And we'll make the color red. So there's our text. So this will be the upper left-hand corner. Oh, you think it's only going to do it when we actually play?
Yeah.
Let's go back to the center.
Didn't you say Shift and Alt?
I feel like it's like behind that wall. Why was his in the middle of the screen right off the bat? See, I shouldn't have tried to do Canvas. 3D text is really easy. All right. Well, we're going to figure it out. Okay, there it was. Oh, wait, no, it wasn't. We did have it showing up, didn't we?
Could you reduce the height of the wall to see properly if it's
Oh, you think the walls are blocking it?
probably. Okay, I think I know what's wrong. I think you meant to call in right-clicking on the public, in the Unity, in the script, add a UI engine and make it public.
We shouldn't have to do that just to get the text to show up. That's going to be for me talking to the text. Like if I want to change it, we're going to be adding a count later.
I have something similar to this, and because what I did, I had this here, and the text.
Yeah, that's when we go to change the count. When we actually set the text. I just want the text to show up. The change in the programmatically changing the text is going to be easy. We just need the text to show up on the screen.
Okay.
So what's not happening now is our text isn't actually showing up. I just want it to be in our scene. Changing the text for it, that's the easy part. And I mean, we can pretty easily do this. I can come up here to the, let's do it off of the sphere. And I'll create 3D text. Something, like this. Was it in front of the? Oh, it rolls with the ball. That's actually kind of awesome. So we'll offset it from the camera instead of the. So I do it from the camera. I'll reset the position of my text. And then I'll put it at a distance of, I think it'll be 1 in front of the camera. All right, so now it's staying still. We just need to lift it up some. So something like that, and we could squeeze the text down. So that would keep going with it, but I really want to give us like the canvas look that has something that's always on the screen. So, we can make this work pretty easily. If I change the scale. So I do font size of like a 10. Okay, so 0.01. It's pretty sharp if I do that. See what that looks like. So, now it's a lot sharper text, and it just stays at an equal distance in front of the camera, but I want to get that canvas thing working. So I guess for right now, let's get this working, and then we'll go back and look at the canvas thing. So let me center that a little bit better. Call that good enough. All right. So what this guy is he is a 3D text object that I have connected as a child of the camera. And I have it offset at a certain place. Now, one thing, kind of the trick with 3D text, when you saw when I first put it on there, the text was really fuzzy. So what you have to do to get it to not be fuzzy is you increase the font size to something huge. So I made the font size 200, and then you reduce the scale to something tiny. So I made the scale 0.01 on X, Y, and Z, and then a giant font, which then squeezes it down to, what is it, probably a 24 font or something like that, or 32 font from what we would expect. But then the text sits with it. So let's get it working on this first, and then we'll swing back around and get the canvas working, like maybe after we take the first break or something like that. I'm sure it's something stupid we're doing, but this will at least cover the programming logic of keeping track of when we collect something. Okay? Now, right now, if we go back into our scripts, and we're going to go to our collectible script. So this is the guy that's sitting on each of our little yellow boxes. And the collectible script knows when a collision has occurred. So we have this on trigger enter. So remember we put box colliders on those guys. So when the trigger enters, we go ahead and we destroy ourselves from the perspective of that. But before we actually destroy ourselves, we want to kind of record somewhere what has happened. Right? We want to record somewhere that a box has been collected. So we need to have something that has access to the stuff that's on the screen. There's several different ways we can do this. We're gonna show you some different options. All right. So we're gonna start off with the idea of a singleton. So what I'm gonna do is I'm gonna put an empty game object out here. All right. So we're going to create an empty game object, and we're going to call this guy Scene Manager. Okay, this guy's not visible. His only reason to exist is to hold a script that can keep track of some global variables for us. Okay, so I'm going to go ahead and we're going to right click here. We're going to create a new C# script, and we'll call this guy Scene Manager. All right, and inside of the Scene Manager script, we want to go ahead and we want to create a couple of variables. So we're going to create a, actually I need to do static. And let's see, do I need this guy to be a mono behavior? Well, it's not going to hurt anything right now, so we'll just leave it like this. So we're going to say static int count. And then inside start, well, we'll start this off at 0. Okay, static int count. So now what we're going to do is we want to, every single time something updates, every single time we collect one of the boxes, we want to increment this count. So we need this guy to be 1 larger than it used to be. Okay, now this is a static variable that's owned by something in the scene. All right, so let's look at some ways we can talk to this guy. We're going to come back in here. There's my scene manager. That's an empty object. I'm going to go ahead and give that guy the scene manager script. So as far as we know right now, this scene manager empty object has this script that only has 1 variable in it. Okay? Now what we're going to do is inside of our, we have a script associated with camera. Let's go ahead and let's create a script for our scorekeeper, something like that. Okay, and we're going to attach that to the camera. So I'm going to right click here. Actually, do we need to do that? Yeah, let's do it. So we'll create a script here called scorekeeper. And I'm actually going to attach it to the text. So there's my score. I'm going to have scorekeeper attached to the text. Okay, now notice that my scorekeeper has a text mesh. Okay, and this text mesh is the actual guy that has a text property that I can set. All right, to give you an example of this, right now the default value is 0. Let's go into this scorekeeper script and let's change it to something else, just proving that we have access to it. All right, so what I'm going to do is I'm going to give myself a text mesh tm, and we're going to set this guy, this .tm equal to this .get component. The component is going to be of type text mesh. All right, so then we have access to that text mesh. And then we can say this .tm.text is equal to, set it equal to the string 5, something like that. So through Unity, we've set it to 0. Now, programmatically, we've updated the 0 to be a 5, proving that we've programmatically given ourselves access to that widget. Okay? So because this scorekeeper script is attached to my score text, here's the script, the scorekeeper script is attached to my 3D text called score, and we see that that 3D text called score has a component called text mesh, of type text mesh. So what I'm doing is inside of this script, I'm saying this dot, okay, this is the dude who owns this script, which is my 3D text, get the component of type text mesh. So that's going to give me the text mesh component of that 3D text. And then I'm going to say, okay, now that I have that, go ahead and set the text for that text mesh to 5. All right, so even though I started off at 0 here, we see it's now 5. Because programmatically I altered it once the thing changed. Okay? Now, if I want to go crazy and you want to see the frame rate, we can do something like int cursor. Maybe you start that off at 0. And then inside of update, if you want to go really crazy, we'll set the empty string concatenated with this dot cursor and then this dot cursor plus plus. Just arbitrarily increase the score by 1 every single frame. So we'll see it go up quickly is what we'll see. And you're going to see a flicker, a pretty bad flicker actually. But it'll give us kind of a realistic view of how fast that update method gets called. All right, so we're seeing it update on there. Actually, it's not flickering as much as I thought it would. I wonder if I start moving it. Interesting. Probably don't have enough stuff going on the screen to actually push the graphics card in this very much. Okay, but that's not what we wanted to do, right? What we wanted to do is only increment when we actually have hit something, right? When we collected something, rather than just arbitrarily make it grow. All right, so we don't actually want our current score to come from a local variable here. Instead, in update, I want my current score to come from another script. That is my scene manager script. Did I do a, what does I call it? Count? There we go. So I made it a public variable, but I made it a static variable. What does it mean for a variable to be static? Okay. Practically, what does it mean? If it's static, what does that mean? Okay, we have one of them, right? We don't get a new instance of it each time. We have one. Okay, so I have a single variable called count that's owned by a script called scene manager. I have access to that script called scene manager because I've thrown it into the scene. I've attached it to that empty object just so I have, because I need an instance of that script, right? Each instance of that script only shares that one copy of that static variable, but I still do need the script in order to talk to something, right? Otherwise, the script's just sitting in my asset folder. So that's why I attached the script to this empty game object for the sole purpose right now of having this dude that has a static variable called count. Okay? Now, the reality is, I believe I can do this. Because before, this guy was something called a mono behavior. Now, mono behaviors, from our perspective, they come with a couple of rules or a couple of caveats. They get a start method, they get an update, they get that fixed update. So they get those things, but those things get called every frame or every certain amount of time, whatever it is. Now, do you think that the more scripts that we have in our game that have to call that update method, the worse performance we're going to have? Probably, right? If you have 5 things that are each calling an update method and you make it 10, you've hurt your performance, correct? In this case, Scene Manager doesn't need to have an update. He's literally a bucket for holding pieces of information. So we're just going to make him a normal class, but that normal class happens to have a public static variable in it called count. Now, I believe it does not need to be a mono behavior in order for this guy to access it, so we'll find out here pretty quick. So now, from a scorekeeper perspective, this is the script that's attached to my 3D text. On update, he's going to go ahead and say, Scene Manager, what is the current count? I'm going to update my text to that. Now, the reality is it probably is going to be the same for a while until I start rolling over stuff. All right, so let's make sure that this works initially. So there's my 0. All right, and just to prove the communication, since we defaulted it to 0 to begin with, I'm going to go ahead into my Scene Manager, and let's just start this guy off at 5. It's never getting altered by anybody, but we want to prove the communication between my Scene Manager script and the update method of my scorekeeper. There's my 5. All right, so that means I have this Scene Manager that's sitting here in my scene. So this guy right here, he's an invisible object. He's just an empty object. And that guy happens to be holding on to this script. Oh, you know what? This is interesting. Do I need Let me see if I actually have to have it attached to an object. I don't. Interesting. So the fact that it's in my assets is good enough. It doesn't need to be in the scene because it has the static variable in it. So I actually don't need the scene manager script attached to a game object. It can just exist. So that's actually surprising to me that it would create an instance of every one of my scripts anyways. Well, maybe it's a performance advantage to that. So we didn't actually have to attach it to this. We just have a plain Jane C# object here called scene manager that happens to have a single static variable in it. Okay, there's nothing special about this object. It has nothing to do with Unity or anything like that. This is just a plain C# class that has a single static variable in it. And that static variable we want to be able to change whenever something is collected. That is to say, whenever one of these guys is run over, so on trigger enter for that. So let's go back and let's set this back to 0. And then we'll go to our collectible. Whenever we enter the trigger for our collectible, before we destroy it, we want to say scene manager.count++. Increment our count. So we're yelling at the scene manager script, and we're saying make the count 1 bigger than it used to be. And then we're relying on our scorekeeper on the next frame to update his text to be 1 larger than it used to be, to grab the current version of count. That make sense? See how these different pieces are talking to each other? Okay, so we have this one object here that's holding on to the count. We have this other object here that's a collectible, that this guy knows when something runs him over. Okay, and then we have, so this is the scene manager. So when this guy gets run over, he updates this variable here. And then we have a third guy, which is our scoreboard. And he has a scorekeeper script. And on update, which means every single frame, he checks in with this guy and says, what's the current value of count? So every single frame, he's grabbing the current value of count, and he's updating whenever it happens. Now, realistically speaking, we probably would give ourselves a little bit better performance if we put it inside of a fixed update, or possibly a late update instead of doing it every single frame, because chances are we are not going to be running over our thing 60 times per second, right? If we think about a frame rate of 60 frames a second, but this should still give us, this is going to be as good as it's going to get in terms of, when you run over something, you're going to update your count instantaneously at the cost of performance because you're checking that count variable 60 times every single second, even though chances are we're not changing it that often. All right, so let's go ahead and test this. It should start off at 0. Why should it start off at 0? Because our scene manager has a count initially at 0, and our scorekeeper on update just shows whatever the current count is from our scene manager. Now, every single time we run over a collectible, before it gets destroyed, our collectible lets the scene manager know that it should be 1 greater than it used to be. So these objects should now be working together. Uh-oh, ruh-roh. Okay, so let's see if I can prove something here. I'm going to steal this variable. We're going to delete this. I'm going to delete that. No, it did update. Because we were updating it through the count there, so that means this guy wasn't actually updating it. . There's our scene manager script again. So on trigger enter for this guy is when we should be killing it. Except, is that guy ever actually getting called, or are we doing it from the bumper perspective? Then we have another script. Is it movement? I think this is where it's actually getting destroyed inside of the collect. Because this guy is the guy that gets called. Who calls collect? And we send a message. Yeah. So it was our bumper. So we faked ourselves out. Inside of this collectible, we were messing with this last time, but we actually don't actually have a trigger on our collectible anymore. So this scene manager count plus plus, we do want that to happen when something is actually collected, but this is not the code that collects something. That guy doesn't do anything. That was our old code from last time. What actually does something is bumper CS. This guy says when something hits the bumper, remember what we did? We put that big disc thing. You know, we flattened out a sphere and had that, or I don't remember if it was a sphere or a square, whatever it was, but had that be our bumper. And it's that guy that runs into the collectible things. And when that runs into the collectible things, we ask ourselves, is the thing I just bumped into a collectible? Is that the tag associated with it? If it is, I'm going to send a message to the player. Okay, that's associated with me. That message is going to be the collect message. And I'm going to pass it the game object that I hit. So now back here in movement, we have this function called collect. This guy got called by sending the message to the player, because the player has a script on it called movement, and the player received the message called collect. He checks all of his scripts, sees that he does have a script called collect here. So it's in this script that we want to go ahead and increase the count. That we literally just collected something and we want to go ahead and destroy the dude we collected. Okay? So now, when we go back in, there's our 1, there's our 2, so on and so forth. All right, does that make sense? How that's working? All right, so let's go. Oh, you have a question?
Do you still have the text that floats around the ball because it looks like there's something?
I don't believe so.
As you get close to the wall, you can see it in the shadow.
Yeah, I do see what you're talking about. I don't think that's text.
Because before we had the 0 that was floating around the ball.
Yeah, I know what you're talking about. Oh, this is our 3D text from last time. So yeah, this is what we were doing at the end of class last time, doing it with the 3D text. All right, so questions on any of that? All right, so let's go ahead and let's take about a 10-minute break, and during that time, I'll try to figure out what's going on with the canvas thing. I'm sure it's something stupid that we're doing. Because clearly having the canvas set where it's always in view is going to be better, because otherwise we need to put 3D text here, just have it always offset. We can pull it off, but the canvas is purposed for this exact thing. So let's figure out what's going on with the canvas. So let's take 10 minutes, and then we'll hopefully I'll figure it out in that 10 minutes, and then we'll come back.